Today, technology has us living in two worlds. Everything from the way we work, communicate, and even interact with our environments is moving us increasingly toward a more interconnected digital existence. But it isn't only people who are making this technical transition. In fact, as we look to develop our societies toward more convenient, sustainable, and healthy ways of living, how might this digital duality allow our buildings to think smarter? Over the past few decades, we've seen an astonishing rise in the rate of urbanization. If projections hold, as much as 68% of the world's population might be living in urban areas by the year 2050. The increased demand to construct buildings to accommodate this boom means the race is on to find more efficient and sustainable ways of designing our infrastructure. That's where digital twins come in.
A digital twin, it's a great term, but it's basically taking the idea of an asset that you would have on paper or in your head and applying a digital version of that. So taking the physical idea, but digitizing that so you can play many different scenarios of how that asset can be constructed and then also be maintained.
It's a technique that has seen rapid growth across all aspects of manufacturing, everything from cars to utility networks and even entire production lines. Why? Digital twin technology goes beyond 3D modeling to testing the long-term viability of a design. And that's critical in architecture. By bridging the gap between the digital and physical worlds, these highly advanced digital doppelgangers allow architects to analyze data, stress test materials, and even monitor the overall running costs of a building, long before construction has even begun.
The big difference here is that you can run the building acting like it's connected to the utility grid. You can run the building making assumptions of how many people are going to be in the building. Think about a building, if there's 50 people or 200 people, there's different heat loads that people put off. And so then what do you need for a cooling system in the building? And that's where we come up with our mission of creating smart infrastructure in the world.
Diagnosing problems, simulating the full life cycle of the building, even simulating how people walk through a building and populate the space. The adaptability of digital twins have made them a sought-after tool. But while the digital twin market is estimated to grow from $5.1 billion in 2020 to $115.1 billion by 2035, there's still more to do toward a wider spread implementation.
Today, there's not a car that's being designed without creating a digital twin up front. Right now, there's a whole part of the industry that's focused on the upfront cost, and then there's a separate part of the industry that's focused on the operating cost of a building. These two, for the most part, not 100% of the time, are in silos. And so what we need to do is we need to bring those two constituents closer together.
Digital twins can bridge the gap between the twin imperatives of construction and operations. Siemens is focused on using them to create sustainable buildings in the real world.
The building is a self-monitoring, self-healing itself, self-scheduling a repair before the need occurs, and therefore it becomes more alive. We're starting to connect the digital world and the physical world and really pushing the digital applications into the marketplace for the good of the environment, the good of our customers, and improve the value to our customers' operations.